Question number first, exercise 10.1. The question is if tangent alpha is equal to 3 divided by 4, secant of beta is equal to 13 divided by 5, neither the terminal side of the angle of measure alpha nor beta is in the first quadrant. So from the article, from the definition, we know that when the tangent function is positive in the first and third quadrant, and secant of beta is the value of secant of beta is positive in the first and fourth quadrant. So alpha and beta, alpha is in the third quadrant and beta is in the fourth quadrant. And to calculate sin alpha plus beta, cos alpha plus beta, and tangent alpha plus beta, for the calculation of these quantity, first we have to calculate the perpendicular, base and hypotenuse from the given data. Since tangent of alpha is equal to 3 divided by 4, which is denoted by y divided by x, y, this quantity will be perpendicular and this quantity will be the base according to the definition of tangent function. Alpha is in the third quadrant because tangent alpha is positive in the third quadrant. So x and y both will be negative in the third quadrant. Compare this data with y1 divided by x1. We have y is equal to -3 and x is equal to -4. Y will be the perpendicular and x will be the base. To calculate r, the hypotenuse, we have by Pythagorean theorem, r square is equal to x square plus y square. Substitute the values of x and y. We have r is equal to 5. 5 is always positive. 5 is the hypotenuse is positive in each quadrant. To calculate sin alpha will be equal to perpendicular divided by hypotenuse with respect to alpha. Y is perpendicular, and r is the hypotenuse, which is equal to y is equal to -3 divided by 5, and cos of alpha is equal to base divided by hypotenuse. So base in this case is x and r is the hypotenuse. So x is equal to -4 and r is equal to 5 in this case. Let us take another function, which is secant of beta, which is equal to 13 divided by 5, and beta is neither in the first quadrant, so beta is positive in the first and fourth quadrant. So beta, the terminal ray of beta will be in the fourth quadrant. We have secant of beta is equal to 13 divided by 5, which is equal to hypotenuse divided by base. The hypotenuse is denoted by r1 and the base is denoted by x1. Compare this data. We have r1 is equal to 13 and x1 is equal to 5. Beta is in the fourth quadrant. To calculate the perpendicular, we apply the Pythagorean theorem, which is r1 whole square is equal to x1 whole square plus y1 whole square. R1 whole square minus x1 whole square is equal to y1 whole square. Substitute the value of r1 and x1. We have 169 minus 25 is equal to y1 whole square. And after the simplification, we have y1 is equal to 144. Taking the square root, we get y1 is equal to plus or minus 12. Beta is in the fourth quadrant, therefore y1 is equal to minus 12. Now to calculate cos of beta, therefore cos beta will be equal to base divided by hypotenuse. This is the base in hypotenuse, which is equal to x1 divided by r1, which is equal to 5 divided by 13, and sin of beta is equal to perpendicular divided by hypotenuse, which is equal to y1 divided by r1, which is equal to minus 12 divided by 13. So now to calculate the first part of this question, which is sin of alpha plus beta. So sin alpha plus beta is equal to sin alpha cos beta plus cos alpha sin beta. Substitute the value of sin alpha cos beta cos alpha sin beta from the given data, which is calculated is given by minus 3 divided by 5 multiplied by 5 divided by 13 plus minus 4 divided by 5 multiplied by minus 12 divided by 13, and after the simplification we get 33 divided by 65. To calculate the second part of this question, which is cos alpha plus beta, so expand cos alpha plus beta, which is equal to cos alpha cos beta minus sin alpha sin beta. Substitute the value of cos alpha cos beta sin alpha sin beta from the given data. From the calculated and given data, we have cos alpha plus beta is equal to minus 56 divided by 65. And to calculate the third part of this question, which is tangent alpha plus beta is equal to sin alpha plus beta divided by cos alpha plus beta, which is equal to sin alpha cos beta plus cos alpha sin beta is a whole divided by cos alpha cos beta minus sin alpha sin beta. Substitute the values of sin alpha cos beta cos alpha sin beta in the numerator and denominator, and after the simplification we have tangent of alpha plus beta is equal to minus 33 divided by 65, which is the third part of this question.